Okay. All right, so this is our code 2123 engine dynamics. Okay, we have gone through all the assessment component. So we have 2 tests for this module. 2 tests, 1 assignment and 1 exam. Today we start chapter 1. Again, I'll be using these 2 books along the lecture. If I use a new one, then I will let you know in the lecture. Okay, so chapter 1, today we're going to look at the kinematics of particles. We will look at a little bit on what is kinematics, what is rectilinear kinematics. Then if we have time, then we go into curvilinear motion, and projectile. So our objective today is to cover these 2. Okay, then next class these 2, or maybe 3. Okay, so today our objective is to solve kinematics problems, introduction to kinematics, and we look at rectilinear kinematics motion. All right. Okay. Right. So what is mechanics? Right? What is mechanics? Mechanics is something that is a physics or science that related to motion. To a motion. Okay. It can be two types of motion. One is rest, and also something is moving. Okay. It can be rest or it can be moving. So the first we look at today is definition of mechanics. All right. So under entry mechanics, we have another 2. We look at static problems and dynamic problem. So I believe you have already learned about statics. Now we learn about dynamics. All right. Now, what is statics? Statics is something that in previous module, right, in one of the module, when you learn about statics, you always learn about equilibrium. Right, all the force equal to 0, all the moment equal to 0, then you find the missing parameter. Okay, and when you learn about statics, the velocity will be always constant. Okay, the velocity will be always constant. However, when we look about dynamics in this module, something will change. When you look about dynamics, also we are linked with equilibrium, means all the force equal to 0, all the moment equal to 0. However, we will deal with accelerated motion. Okay, so static, you learn about constant velocity, means velocity always constant. However, in this module, when you learn about dynamics, we learn about change of velocity. Acceleration, you take 2 velocity divided by the time. Okay, so in this module, most of the time you deal with acceleration. Okay. All right. Let me clear something. Okay, let me clear the text. There's something inside my slides not belongs to the lecture. Okay. Now we have done defining the. We have done defining the static and dynamic just now. Any question? Do you see the difference between static and dynamics? Okay, I hope you can see. The differences is one is constant velocity, one is the velocity is not constant. That's why in this module, when you learn about dynamics, you need to find acceleration. Now, inside dynamics, we look at another 2 more components. Okay, we look at 2 more components. 2 wording that quite similar. The first one is called kinematics, another one is called kinetics. Now look carefully on the spelling of the word kinematics and kinetic. Kinematics, we will study about the geometric aspect of the motion. Meaning, what does it mean? It means we look at the motion and we study how the motion behave in the Cartesian plane or in the positioning system. Okay, so geometric means we have a position for the motion. Kinematics. However, for kinetics, we will look at forces. Okay, so definition for statics, dynamics, kinematics, kinetics. Any question so far for these slides?
No, sir.
Everyone clear? Okay. So there are suggested steps when you solve kinematics problems for this module. First, we will repeat this kind of steps many times, and if you practice enough, you will subconsciously you will follow all these steps. First, read the question carefully. All right. So when you solve kinematics problems or engineering dynamics problems, first read the question and then try to relate, oh, this question related to chapter 1. This question relate to question 2, chapter 2. This question relate to chapter 3 and so on. Okay. Read the question and relate to the theory that you learn. Okay. So each chapter have their distinguished or special or significant description or special situation that fit to that chapter, right? So today we learn about kinematics of particles. So every time you see particles motion in the Cartesian plane, that where you can plot x and y, then it fall under chapter 1. Okay, so the first step, read the question and relate to which chapter is that. That question related to which chapter. Then it's highly recommended that you visualize the question using diagram. Means you sketch the situation on your answer sheet, and then if you have given some data, you write the data on together with the diagram that you draw. Okay, first read, second you draw. And for this module, there are some points for the diagrams. There are some points for the diagram. Minimum 1 mark. Minimum 1 mark for diagram. So you're given a question, you draw the diagram, you draw the x, y, sometimes z dimension. You put into the diagram to show that you understand what is being asked, and you show the attempt to solve the problems. Okay. The third one. Once you draw the diagram, input coordinate system, meaning you draw your y-axis, x-axis. Sometimes in 3D problems later on, you need to put in the z-axis. Okay. First read, second draw, third put in the x, y, z axis in the question. All right. Next, by looking at the question, by looking at the coordinate system and diagram, there will be one equation or two or maybe three equations that you need to solve. Solve the question according to the question. Solve the equation according to the question that you see. And just a reminder, you are always given a different unit in the question just to test your awareness. Remember to use the correct unit for your answer. All right. Now, unit SI, for example, unit SI, length is meter, time is second. So sometimes the question in the exam or test will purposely give you the question, for example, in 10 cm or 10 mm. You need to change them into meter. Okay. Or sometimes we give you Sometimes give you time in microsecond. So you need to know what is microsecond in your answer. Okay, you need to write the correct unit. All right. After you solve the question, you look back at your question at your answer. Does it make sense or not? All right. So for this module later on, you will see all the direction to the x direction, right? To the x direction will be positive, means horizontally to the right will be positive, going up will be positive. So if you look at your answer, does the motion of the things, the motion of the component or motion of the molecule or motion of the particles, does it make sense or not? If you're given a certain action to that particular particles, for example, if you push the particle to the right, it will move to the right. So check your answer. Sometimes you make mistakes in the equation. Sometimes you forget about the positive and negative. Then in your answer tell you that the particle, when you push to the right, the particle move to the left. So it doesn't make sense. So you need to check your answer. Okay. The next one. Once you solve, this is an extra one. The last step will be you review your answer. Means you look back your question. You look at the question. You look at your answer. Does it fit into the correct chapter or not? Do you use the correct theory or not? So you don't mix chapter 1 answer with the chapter 6 answer, for example. All right. When a question asks you chapter 1, you don't answer question that you learned in chapter 6. All right. If you've been asked about force, you don't give answer in moment, for example. Okay. So these are the recommended steps, and we will keep using these 6 steps throughout the module. All right. Now we start learning new things today. We will look at kinematics problems with continuous motion. So let's say we have a particle that you see on the screen there. There's a yellow dot there. Let's say we have one particle in the air, and we assume that this yellow dot there move in the straight path. Now this morning we start with a very simple case where particle move in the straight path. In a straight path. So as we learn deeper, you will see that the particles start fluctuating and moving in a complex behavior. So today we start with a simple motion where this particle move in a straight line. So let's draw a straight line. Okay. So, and then we will label the starting point or initial point, starting point with O, origin point. O or 0 as origin point. So when we talk about motion, we have to know position. We have to know the original position and the last position. Okay. So let's say these particles move from the left to the right in the straight path. So we start solving kinematics problems, and this one fall under rectilinear or rectilinear. So it's a linear, the wording linear inside there. Linear means straight line. Or if you learn about mathematics, you learn about linear equation, right? So what is a general equation, general form of a linear equation? You get y equal to mx plus c, right? Y equal to ms plus c is a linear equation. So recall back some of the mathematics concept that you learned. You have linear equation, you have quadratic equation, you have polynomial equation, and so on, right? So for the first session, we learn about straight line. You learn about rectilinear. Rectilinear, the wording linear means you deal with linear equation. All right. So we will look at 3 important things when we talk about kinematics. First, position. Second, velocity. Third, acceleration. So these are the three keywords when we deal with kinematics problems. We will start with what is position. Then there is an equation to calculate velocity. There is a calculation for acceleration. So what mean by position? So go back to the diagram. So this yellow dot here move from origin 0 to this position. So there must be a distance travel from the origin to this position. We label as S. Okay. Or previously, some of the lecture, they use S as a displacement that you learned in statics, right? S. So S is a distance that travel from origin to the end position. S. So again, just a reminder, we are dealing with vector in this module. Particles position, or the word position itself, is a vector. Now, if you recall what is the definition of vector, vector is a quantity that have direction and magnitude. All right, position is a vector. Vector, you have magnitude and direction, meaning you can draw position as a vector using this is not the right one. So you can describe a position with the vector where you use an arrow, and the length of the arrow will define position, right? Vector, you have magnitude and direction. Next one. Again, just now we introduced you three important concepts or three important keywords when you solve kinematics problems: position, velocity, acceleration. We start with position first. Again, a new, not new, but something new for today. Remind yourself that position is a vector in this module. Okay. And next one, we call displacement. Displacement, that what you learn in your normal physics class. Displacement is a change of position. Just now we define position, right? So when in the question or in the final exam later on, you will see displacement, find displacement, or calculate displacement, or determine displacement of that particular particles. So displacement, it means there's a change of position there. How do you find displacement in a straight line for these particles? So let's say this particle move again from this position to this position. So the displacement, you can use this equation. Displacement is a change of location or change of position. You use delta S to represent displacement. And quite straightforward from the screen here. Displacement, you take the S comma, means the new position, displacement, new position minus the old position. Okay, let's review back. How you get the S? How you get the first position? Again, location is very important in kinematics. So how you define the S? You always refer to the origin position. Or in this diagram, you see the O there. S measure from initial position O. S, comma, also measure from origin position. So bear in mind, when you solve kinematics problems, always know where is your origin. So start from today, when you start solving kinematics problem, always know where is your zero, where is your origin, because it will give you answer for location, for your position, and also displacement. Okay, so I think this one is the first equation for today, and I think you're familiar with this one. Okay, first equation for today, what is displacement? All right, so write this one. If you already download the tutorial question, write this one for the related tutorial question. There is one question in the tutorial asks you to define displacement. Okay. Now, again, just now, position is a vector. So displacement is a differences of two vector. So displacement also a vector. So delta S, displacement, also a vector. Remind yourself how you define a vector. Vector have magnitude and direction. Magnitude, the length of the arrow, and the arrowhead from the arrow from the tail to the arrowhead is the direction of that vector. Okay, so you need to recall how to calculate problems with vector. All right. Okay, so what have we done so far? We define the position S. We define displacement delta S. Okay, so there are two different terms here, position and displacement. Okay, now we look at velocity. How do you define velocity? And in your diagram, in your answer, we will always assume direction to the right will be positive. Or later, when you plot XY direction, XY axis, along x-axis to the right will be positive. How do you define velocity in kinematics problems? We will refer to interval of time, delta t. So if you talk about a motion of a particles and you define the motion of particles in velocity, the first type of velocity we call it average velocity. Average velocity, V sub AVG represent average velocity. You take the change of position or displacement. Okay, you take displacement divided by time travel from this position to this position, delta t. Another velocity. Again, velocity is a vector also. Another terms that you learned this morning. This is what you learn when you talk about statics, because in static problem, this velocity will always constant. However, for dynamics problems, this one will change. So another terms that you learn, we call instantaneous velocity. I highlight with a yellow color. We write as V, and we put a limit there. And if you see a delta S means very small changes of your displacement divided by very small changes of your time, you can change the delta sign into ds over dt. Now this is a mathematics steps where you use limitation of your time. This one fall under your calculus or mathematics 1 and mathematics 2. Okay. So what is important for this module is that you have two different description for velocity. Sometimes the question asks you to solve average velocity. You use this one. Sometimes the question asks you to find instantaneous velocity. which is v. V equal to ds over dt. When you use delta sign, means a very, very small distance, right? In the particles dimension, very, very small, we use delta. If something that you can measure with your ruler or with your instruments, something that can measure, then we use the D symbol rather than delta. If you can measure with your ruler, we won't use the delta. We will use D symbol. So for these slides, you will see there are two different velocity. One is average, one is instantaneous velocity. For this module, we will always use this one rather than this one. Okay, so this one you learn in your statics. In engineering dynamics, we will use this set of equation. All right, stop me if you're not, if you don't understand or something seems weird to you. All right, so we have clear velocity. Any questions so far?
No, sir.
Clear? Okay, good. So second equation for today. This one. Huh? First equation, how to find displacement. Delta S. Second equation is V, instantaneous velocity. I label in the yellow color. Two equations for today. These two, I think you recall from what you learned in your SPM physics class or maybe it's in your static module also. Okay. So this is another highlight. I highlight for you. So for kinematics or for engineering dynamics, the direction is very important because we deal with vector. Okay. Displacement is a vector. Velocity is a vector. So direction is very important. Okay. Vector, you have magnitude and direction. So we will always define direction to the right will be positive. So I'll explain this one later on when we go into tutorial question. Okay. All right. So always have this as your reference. You always need a reference point or reference direction so that you know when you solve your question, when you get your answer, if you get negative, what does it mean? When you get positive, what does it mean? Okay? All right. Just a reminder, since velocity is a vector, you have a direction and magnitude. So the magnitude of velocity, we call it speed. And the unit of velocity, the unit of speed is in meter over second. This is just a reminder. So for this module, when we mention the word speed, it means magnitude of the velocity. Don't confuse between velocity and speed. So you already enroll in engineering dynamics. So we are in engineering dynamics module. So in this module, be careful when you mention speed and velocity. Speed is a scalar and quantity. Scalar quantity means you don't have direction, you just have a magnitude. Okay, so differentiate between velocity and speed. In your answer in test 1 and final exam, be careful when you use the wording speed and velocity. If the question asks you to solve velocity, give your answer in velocity. If the question asks you to solve speed, then you give speed. Okay. So we deal with average velocity. Average. Just now we learned about average velocity. What if the question asks you to solve average speed? How do you find average speed? We will use the symbol V as P, V sub SP to represent speed, right? To differentiate the velocity and speed. So velocity we use V, or sometimes you don't write average. If you write V, it means velocity. If you refer to speed, then you use SP below the V. How do you define speed? I highlight with the orange color. You take ST divided by delta T. What I mean by ST? ST is the total displacement that the particle had made. Total displacement that had been made by the particles divided by the time traveled by the particles. I'll give you one diagram later on. There's a differences between velocity and speed. Velocity is a differences in displacement, delta S or ds. However, if the question asks you to solve speed, you need to take the total distance traveled divided by delta t. This answer and this answer might not be same in engineering dynamic module. Okay, in static, these two will be the same. However, in dynamics question, these two will not have the same. By looking at the equation itself, you know it is different. I'll give you one diagram. So third equation for today, speed equation. This is for average speed. Yeah? I'll give you a diagram. The two equations that we discussed just now, velocity and speed. Let's say these particles travel from origin 0 to this position, P. And after this, the P continue to move in the curve. He start to roll back to this position, P, comma. By using these two equations, if you calculate the velocity, you use delta S in your calculation. It's a displacement. You use delta S, where the position, the initial position, compared to the end position, you find average velocity. However, to find the speed, you're using ST or total distance traveled by the particles from P to the P, comma. You need to measure from this point and then along this curve and to the end. This is the distance traveled by the particles to find the average speed. Any question by looking at these two equations and this diagram? So by looking at this diagram, you know that the answer for average velocity and average speed will be different. Okay. Now by looking at this diagram, which one will give you higher value? Which number will give you, which answer, either the green color or the orange color will give you higher answer compared to this diagram? Anyone want to try to answer? Shilton, are you here? Let me check attendance. Okay, Shilton not in the class. Okay, Nareswaran, you want to try to answer by referring?
I think the average speed has a bigger value.
Okay, why?
Because you're talking about the total distance that's traveled. When you're talking about average velocity, it's probably during a smaller distance,
Mm-hmm.
displacement.
Mm-hmm. Correct. So, correct. The answer is correct. So,
Thank you.
as you can see from diagram, st, I mean the time is same. The time will be the same. However, if you look at the speed dimension, it concerns about the distance travel. And in this diagram, the line of this curve is longer than this delta s. So, according to this diagram, the value that you calculate in your answer, average speed, will be bigger than average velocity. Again, from these slides, you can differentiate between velocity and speed. I hope you can differentiate from today onwards, especially when it comes to engine dynamic class or engine dynamics question. Be careful when you mention velocity and speed. Of course, outside this module, you talk with normal people out there, velocity and speed will be the same. But however, as long as this module concern, when you're in solving question related to this module, there is a difference between velocity and speed. Yeah. Okay. So again, yeah. So yeah. Okay, this one is the same. Right. So one more highlight here is that for velocity, do you see the negative sign here? Do you see a negative sign? So there's a difference between this one and this one. Why we put a negative sign there? What do you think? Based on what we discussed, I think 10 minutes or 15 minutes ago, why do you think there's a negative sign for average velocity?
Because it's going the opposite direction, sir?
Yes, correct. Because we already defined for this module, by in general, all the motion to the right is positive. So if you calculate about average velocity, the displacement always refer to the starting point and end point. So in this diagram, the particles move opposite direction of your x direction, right? Or your predefined reference direction. So it moves back, so your delta s, there's a negative sign there. So there are two differences. One is the value or the magnitude that you calculate. Another one, from these slides, you have to take note for this module, direction is another factor that you need to consider. Okay, there's a negative sign according to this diagram. This also a major error, or student will make mistakes, this kind of error in test or final exam. They will forget this negative sign when it comes to test or final exam. Okay, so take note on your revision notes or on your notes itself. Always look for direction, origin, and the end position. Does it match the positive or negative sign? So this is, you need to check. Okay. Can you guys go a little bit more? Or you need a short break?
Again, sir.
Okay, yeah? Let me know if you need break, yeah? All right. We have done, in continuous motion, just now I mentioned there are three keywords: position, velocity, and acceleration. The next one, we look at acceleration. So when talk about acceleration, again, this should be your normal practice from today onwards. Always have your reference position or reference position 0, and the direction to the right will be positive. When you talk about acceleration, there will be different velocity between two positions. Again, in static, you won't see these problems, but when you talk about dynamics problems, there will be a V and V, comma. It means there's a change of velocity from this position to this position. We will use A to represent acceleration, and acceleration also a vector. It has magnitude and direction. And if you look at this diagram, the direction is to the right. So you have a positive A to describe this situation. Again, just now we see average velocity. For acceleration also we have average velocity, acceleration. We will look at the time interval of delta t. So when you want to solve question about average acceleration, you take A sub average, AVG, or if you're hardworking, you can write the full average here, equal to delta V divided by delta T. Again, V here represent velocity. Delta V, you take this one divided by this one. Okay. Another one, instantaneous acceleration. It means we no longer use the delta sign. We use limitation of t. We can change mathematics. We can change the delta sign to d to find the instantaneous acceleration. So there's a difference between average and instantaneous situation. Yeah? Same for velocity, apply to acceleration. Again, remind yourself, vector, velocity is a vector. So when you do calculation between two vectors, you still get vector. So acceleration is a vector also. Remind yourself, vector have a magnitude and direction. Fourth equation for today. A equal to dv over dt. So this, I think this one is just a refresh for you. Continue from static module. Again, be careful on the direction because this is a vector. So if you get a positive value for A, it means it moves to the right. Okay. Sometimes in question, we will not give you the velocity. When it comes to test or final exam, you need to find the V disposition. V disposition. In a question we'll give you the position of the particles at that particular time. So you can transform this acceleration equation relate to position, substitute this one inside here, meaning if you differentiate double differentiation of your velocity, you will get acceleration. So this is how you write acceleration in terms of position. This is how you write when you write your acceleration or instantaneous acceleration in velocity term. There are two ways you write acceleration. One is velocity. This is a general equation for acceleration. You need to look at the question. If the question gives you velocity, you use this one. If you look at the question, there is no velocity given. You're given the position S, this one, and the time given between these two positions. Then you use this equation. Okay, you find the velocity, then you differentiate one more time, you will get acceleration. Normally, velocity will be given in an equation. Okay, in an equation. So equation, when you differentiate one time, you get velocity. You differentiate one more time, you get acceleration. Meaning your S sometimes will be given in the equation. Recall back what you learned in your Mathematics 1 and Mathematics 2 sometimes, or calculus or advanced mathematics in differentiation and integration. Okay, so in this module, you need differentiation and integration skill to solve question. All right. So we have done position, velocity, and acceleration. So just remind, this is also another add-on. What happens if your velocity is constant? Your acceleration will be 0. This is an untold information that you see in final exam question, where we will purposely put this statement in the question. We'll ask you to find something with a velocity is a constant value. Okay, why this statement is a truth? What happens if your velocity is the same, meaning there's no difference in velocity, 0 here? You 0 divided by time, you still get 0. So again, put this statement somewhere in your notes. When you see velocity is a constant, acceleration straight away equal 0. So this statement will give you 1 mark if the question asks you about acceleration. Or sometimes you need to use acceleration in your calculation. You see the question mentioned constant velocity. You write this statement, you get 1 point for your answer. Meaning you understand what happened when the velocity is constant. Again, this is the bonus point. Important to score for the coming test 1 and final exam. This we won't tell you, but we will purposely mention velocity is constant. So you write this sentence statement in the answer, it will give you 1 point for that. Or you can write velocity constant, a equal to dv over dt equals 0, you get 1 point for showing your understanding what happens if velocity is constant. Okay. Another one, next slides will be okay, this one you familiar already. Position, velocity just now. A, we cover equation for velocity and acceleration. And if you see D, it means instantaneous. So D and D. So can you relate these two quantity or these two vector with delta t? How do you relate this one? Velocity and acceleration in terms of t. So if you put these two equations together, you see that there's something same in these two equations, which is the dt below the equation. So you put two equations together, you pull this denominator dt to the left, you pull v below here, you switch position, you get first equation, dt equal to ds over dv. You do the same for acceleration. You pull the dt to the left, you pull a over here, you get dt over dv over a. So if you're referring to the same particles, if you find velocity, if you find acceleration, the dt will be the same. So if dt the same, you can write ds over dv equal dv over dA. And you can continue using this equation to solve question related to velocity and acceleration. So I don't like the different, the partial or fraction pattern. I don't like this pattern. Of course, you can use the fraction pattern on the far right there, but I prefer in the horizontal terms. I like this form rather than the fraction form. So I pull the A to the left and pull the V to the right. I can rewrite the equation as A ds equal to V dV. Remember this one, we will use this one in tutorial question or in the lecture later on. I think this one is the fifth equation. When you use this equation, when you're looking at the particles that happen, the same particles that happen in the same dt, and you want to relate S, V, and A together, you can use this equation. And this equation, if you learn about integration, you put in integration there, you're able to find the missing parameter. This is a very powerful equation where this equation alone, you can solve acceleration, you can solve displacement, you can solve velocity in one equation. Okay, add in the integration sign, you manage to find the missing parameter here. So this is the fifth equation. All these you're familiar with. Only when it comes to engine dynamics, we try to link up what you learned previously and develop a new way in solving kinetic problem or kinematics problems. Okay. So recall, we learned about displacement, we learned about velocity, we learned about acceleration. Okay, equation that we learned. So what happens if you rearrange this acceleration equation? You pull the dt to the left, you get dv equal to a dt. Okay, we go for a few more slides, then we have a short break. Okay, so we write a equal to dv over dt. We try to integrate now. So a equal to dv dt, you pull your dt to the left, you get this one, dv equal to a dt. This one, this equation gives you velocity in the function of time. Okay. So when you put this, when you see this equation, you put an integration sign in front and in front here, you get this equation. This equation, you differentiate from initial velocity, we write v0 to the end velocity, we use v. Again, call back, this is an integration concept. It's nothing to do with engine dynamics. This is a integration mathematics problems. You integrate to limit, you integrate from origin to the end. Same with here, because how you know what to use for this here? You refer to the dv. If you see dv, you integrate velocity. If you see dt on other side, means you look at t. Don't confuse, huh? Some students, they confuse when it comes to integrate. How you know what limit to use? It depends on the d something. If you see dv, you use velocity. If you see dt, you use time. So time 0 to the end time of the end position. I put a special sign here, AC. It means we have a constant acceleration. We have a constant acceleration, then we use A sub C to represent constant acceleration. Okay, so from here to here. Any question? Stop me if you're not able to relate information that you see on the screen. Here to here. This will be another equation that you will use quite frequent for your test 1 and final exam. Any question?
None so far, sir.
Okay. All right. So when you integrate from here to here, you'll get this one. Okay. So when you integrate, actually this one is 1. There's 1, although there's nothing here, but Actually, there's 1 inside the integration here. So when you integrate this one, you'll take v minus v0. Okay? The final velocity minus final velocity minus the initial velocity, you get v, equal, how you get this one? How you get this equation? All right? So just now you have a v minus v0, right? You pull your minus over here, you get positive. How you get this one? You integrate this one, you add a t in the equation, ACT. Actually, it's AC, comma, or bracket, t minus 0, but you take out the 0, at the end you arrive at ACT. Okay, from here to here actually is a basic integration. Another important equation that we will look at later in a tutorial question. We derive the equation to calculate velocity, initial velocity, acceleration, and time. Okay, this is one of the Newton equation that you learn. Okay, second equation. Just now we deal with acceleration, a dv dt. We use the same concept for velocity. Velocity, definition of velocity is displacement divided by time. You pull dt to the left hand side, you can write ds equal to v dt. Again, you repeat the same concept. You integrate ds, integrate dt, you get this equation. We always integrate from initial displacement to the final displacement, initial time to the end time. Again, how you know what to differentiate? Look at the ds or the d something. If you look at ds, you differentiate, integrate displacement. If you see dt, integrate time. You do your integration steps. Okay. So here you do not see t, right? But you can write your v just now, the equation just now. The v equal to v0 plus ACT. How you get this one? Refer to the previous slides. I think 5 minutes ago, we explained about this one. You substitute this one inside here. You do integration. You substitute this one inside here. You get this one. And you do your integration steps. You get s equal to s0 plus v0t plus half ACT squared. Okay. How you get s0 here? Because when you integrate this one, you take s minus s sub 0. So s minus up 0, you pull your negative s sub 0 to the right hand side, you get positive. How you get this one? You integrate v0, you integrate, you add a t behind. Because you integrate t, you add t. If you integrate s, you add s. But this one is t. So you integrate, you get vt plus. How you get this one? Again, test your integration skill. T, you integrate with t, you t power 1 plus 1, you get 2, you divide it by 2. So you get half AC t squared. You get a second equation to solve kinematics problem. This one is important. This one is important. This one to solve velocity. This one to solve displacement. Third one. This equation just now, be familiar. A ds equal to v dv. We use the same concept. We integrate left hand side, integrate right hand side. Again, how do you know what you integrate? You look at the ds. On the left hand side, you integrate ds. So your limit is s. Displacement from 0 to n position or n. Yeah. Then on the right hand side, you integrate dv, so velocity at 0 to the end velocity. When you integrate this one, you will get a inside here. A is the constant value. You pull AC outside there. So when you pull outside, there's 1 there. AC times 1 inside there. So 1, you integrate the S, is actually you take S minus S0, you get this one. This one is a normal integration. V dv you integrate. V power 1 you integrate V. 1 plus 1 you get 2 divided by the new exponential, you get half. So you integrate from V to V0. This is a normal integration. Again, if you're weak in integration, go back to your mathematics textbook. Okay. And you start rearranging so that you help you to use the equation more effectively. You move your 2 to the left, you get 2ac s minus s0 equal to, again, you use the limit of your integration. So you substitute v inside here, so you get v squared minus v0 squared. And we like to put our equation with v in front. So this is the new equation that you develop. From this equation, you integrate, you get this one, you get v squared equal to v0 squared plus 2ac s minus s0. So these are the 3 important equations. This one, and this one. Okay, go for a break, and then we come back with a tutorial question. Okay, let me stop the recording.